Good morning, everyone. On my way to the gym as per usual, and today we are going to talk about awful problems that are very complicated. We're going to talk about problems, and not just any problems. We're going to talk about computation problems, and this is going to just bear with me now. So in my mind, there are in general two types of problems. You have a fairly deterministic computation problem, and then you have a shifting, a dynamic, a non-deterministic computation problem. Now, I'm using these terms in the broadest sense of, just bear with me, I'll explain. So to me, a deterministic computation problem or a deterministic problem is a problem where you have a set goal. You know what the end result should be at any given moment. You know exactly what the end goal is going to be. So a good example of that is that let's take at the application level, you have a user that needs to be able to purchase a product on your web page. That's your set goal. The beauty about this is that this is what I call a deterministic problem. It's something that you can ahead of time design in such a way that it will work the exact same way every single time for the user. That end result will always be known. You will always know what it's going to be. That's to me a really and luckily that is the common problem. That's usually, as a programmer, that's the usual case for you. You already know what you're going to achieve with the software that you're building, or rather the exact thing. And then you have the other type of problem that is absolutely mind-numbingly horrible to try and solve, but it is also my absolute favorite problem in the world, and I am one of the lucky people who are right now working on such a problem. And that is the dynamic problem, the non-deterministic problem. A good example of a non-deterministic problem, or something that is constantly changing, is relevancy. What do I mean by relevancy? I mean that the sort of problem where it is individually solved for each person that uses your system. Good examples, search engines, such as Google, for example. And at my company, it's about identifying subscriptions for different users. Why is that a non-deterministic problem? Well, because every user has a different payment transaction history, and we, and it's very, basically, no matter how good we get at identifying payments and transactions and so forth, it's still a guess. We can never definitively say this is it. The same thing goes for Google. Google can at no point ever, when it comes to the search engine, say this is the perfect search match for what you typed into the query box for that user. And they can't ask you either. Have you ever thought about that? Google's search engine finds you what you want without ever asking you what you're looking for. How would they figure that out? Well, my guess is, and I don't work for Google, I would love to work for Google, but I don't. And my guess is that the only way that they can figure out if you actually got the thing that you're looking for is what you do after they present the information to you. And that's where metrics gathering comes in. When you have a non-deterministic problem, you have to have a system of evaluating how well you're doing, because you can't test it. And that's why I wanted to make this video. I want to describe to you just how horrible it is to work with a problem. It's amazing. It is absolutely it's such a bittersweet thing. It's the most interesting, tasty problem in the world to solve, and I absolutely love it. But it's also absolutely horrible to test it, because you don't have a way of just running the system yourself and seeing that it's actually going to work. The only way you can do it is in theory. You have to design a system in theory, run it in parallel to whatever you already have, and evaluate which one of the solutions is the better one. And you do that through getting metrics, statistics, gathering user feedback. So in the sense for Google, if I were today to start thinking about how Google probably recognizes if your search, like this is an immense oversimplification, they probably do a million things more complicated than this, but I would do the simplest thing. I would present the search results to my user, and then I would check, does the user click the first thing in the list? And I would give that a rating, because if the user interacts with the first link to a web page that I present, then I know I've got them exactly what they were looking for, most likely. Then of course I would check if they go back and like click on the next thing and so forth, and I would rate that. I would give it a ranking of how well I did. And then I would of course look at things such as how long does it take for the user to click the thing that they're looking for. And I would give, if the user needs to click on to tab number 2 of my search result, then I know that my algorithm isn't all that good. Or, then I know that there's a lot of room for improvement. These things are the type of metrics that you need to gather when you have a non-deterministic problem, or rather a problem that is different for each user that you're trying to help out, right? And that would be my absolute, I'm going to be honest with you, working on the Google search engine, that would probably be my dream job right there. That must be the best, in my world, it would be the perfect problem to work on, because it's so complicated. It's deliciously complicated. It's the essence of figuring out how humans work. It's basically the essence of figuring out relevancy. And that, my friend, is what the entire world of IT, advertisers, everybody in the industry wants to figure out relevancy. If you could break down relevancy, in other words, you could figure out how to provide a person with the thing that they most want without them actually knowing that they want it at the right time, we would live in a very, very nice world. Really. Well, sorry, I get a little bit emotional about this, because these are, as I say, these are the hardest problems there are to solve, in my opinion, of course. But it's also the sort of problems that makes me the most excited, because believe it or not, you may not feel that way now, especially if you're starting out. When you build something, I mean, I was the same when I started. I was so excited about everything in programming, and I still am. I love building things. But when you build something over and over and over, and as your skills develop, your need, your desire to do better, to do more, it increases. And for me, that's exactly it. Even when I was in school, I had ambitions to kind of figure out. I mean, I get absolutely all giddy inside when we talk about machine learning and all kinds of like these more advanced concepts where you deal with, how do I put it, how to solve more human problems, or as I say, non-deterministic problems. Because even if you don't think so, you will get to a point as a programmer where you have built 100 like web applications. You have built so many versions of this thing that it becomes old hat for you. But that's what I love about these type, like the Google search engine problem, because it is a problem that you can't solve. You can't. It's not possible. All you can do is to make it really, really good, and you can always improve it. There's always room for improving, and that's the sort of thing that I love, because I'm one of those guys who I love that sensation of facing something that is so immensely much more complicated than I could possibly fathom, and doing my best to just give it a go. Just sitting down in endless conversations with my colleagues and talking about different ways of solving a problem which I know I will never be able to definitively solve, but I'm gonna have a hell of a fun time trying.